Hello and welcome friends. Let us take a new case of probability. Higher level problems we are going to discuss in this series of lectures. The case is a box contains 3 red and 7 white balls. That means there are 10 balls. One ball is drawn at random and in its place a ball of the other color is put in the box. Now one ball is drawn at random from the box. Find the probability that it is red. That means 2 draws of one ball are made. First draw is made in this situation. There are 3 red and 1 white ball. One ball is drawn and in its place the ball of the other color. That means if the drawn ball is red, we replace it by white. If the drawn ball is white, we replace it by red. So at the time of the drawing second ball, the number of balls will change in any of these two situations. If we draw red ball in the first draw, then before second draw the situation will be like this. Red ball drawn in the first, so 3 minus 1, now there will be 2 red balls and it is replaced by the ball of the other color, means white ball. So now white will be 7 plus 1, 8 and total 10, and now the second draw is made. Or if we draw white ball in the first draw, then it will be replaced by red before the second draw. So now red will be 3 plus 1, 4 and white will be 7 minus 1, 6 and total 10 balls. This can also be the situation before the second draw. So the entire event of drawing a red ball in the second draw can be expressed in two mutually exclusive ways. That is, red ball in the first draw, a red ball is drawn in the first draw and a red ball in the second draw. Or a white ball is drawn in the first draw and a red in the second. See, finally we are interested in calculating the probability that red ball comes in the second draw. But the number of balls, or rather number of red balls at the time of second draw is dependent on the fact that the ball of which color is drawn in the first draw. Red ball is selected in the first draw and then red in the second. Now what can happen? Red ball in the first draw. Red ball in the first draw. It is 3C1 upon 10C1. And now we have selected or drawn red ball in the first draw, so it will be replaced by the white. So red ball in the second draw can be selected out of this situation only, where favorable case is 2C1 upon 10C1. But what if a white ball is drawn in the first draw? Probability of drawing white ball in the first draw is 7C1. Total number of cases 10C1 because there are total 10 balls. And now what happens? A white ball is drawn in the first draw and it is replaced by red. So at the time of second draw, red will be now 4 instead of 3. 4C1 upon 10C1. 3 by 10 into 2 by 10 plus 7 by 10 into 4 by 10. That is 6 by 100 plus 28 by 100. So ultimately it comes to 34 by 100 or 17 by 50 or 0.34 or 34%, blah blah blah. So drawing a red ball in the second row is possible in two mutually exclusive ways. A red ball is drawn in the first row and a red ball in the second row when we have replaced the first red ball by a white, or a white ball is drawn in the first row and a red ball in the second row where we have replaced the white ball by a red ball before the second row. Now this calculation can be made through formula by assigning the sign to each and every event. A1 is a red ball is drawn in the first row. A2, a white ball is drawn in the first row. And B, a red ball is drawn in the second row. P of B, the probability that a red ball is drawn in the second row can be calculated in two mutually exclusive ways. A red ball in the first row and a red ball in the second, or a white ball in the first row and a red in the second. Just compare this with first type of calculation. This is possible through this formula only. Now P of A1, that is probability of drawing a red ball in the first row, it is 3 by 10, and probability of drawing a red ball if a red ball was drawn in the first row, that is 2 by 10, plus P of A2, probability of drawing a white ball in the first row, that is 7 by 10 or 7C1 upon 10C1, and probability of B given A2, that is probability of selecting a red ball if a white ball was drawn in the first row, that is 4 upon 10, 4C1 upon 10C1. So ultimately it is 3 by 10 into 2 by 10 plus 7 by 10 into 4 by 10, that is 6 by 100 plus 28 by 100, that is 34 by 100 equals to 17 by 50 or 0.34 or 34%. So we discussed all the two ways of showing the calculation of required probability. That's it. Thank you very much.